Hi, I'm Len Epp from Leanpub, and in this episode of the Leanpub podcast, I'll be interviewing Andriy Burkov. Based in Quebec City, Andriy holds a PhD in artificial intelligence and is a recognized expert in machine learning and natural language processing. As a machine learning expert and leader, Andriy has successfully led dozens of production-grade AI projects in different domains at Fujitsu and Gartner. His previous books have been translated into a dozen languages and used as textbooks in many universities worldwide. His work has impacted millions of machine learning practitioners and researchers all around the globe. You can follow him on Twitter at Burkov and check him out on LinkedIn, where he's got a very popular following at Andriy Burkov. Andriy is the author of the Leanpub book, the 100-page language models book, Hands On with PyTorch. In the book, Andriy offers a concise yet thorough historical and technological journey from language modeling fundamentals to the cutting edge of modern language models. Within Andriy's famous 100-page format, readers will master both theoretical concepts and practical implementations, making it an invaluable resource for developers, data scientists, and machine learning engineers. In this interview, we're going to talk about Andriy's what he's been up to since he was first on the podcast, his professional interests, maybe the current state of AI in various ways, his book, and at the end, we'll talk a little bit about his experience using Leanpub to produce a course out of this book as well. So thank you very much, Andriy, for being on the Leanpub podcast.
Thanks, Len, for having me. Happy to be back.
Yeah, it's great. You were first on the podcast in 2019. And so I always like to start these podcasts by asking people for their origin story. Anyone interested in that can dig up the old episode where you talk about what it was like growing up in Crimea, and particularly what it was like studying computer science in a city with no regular electricity for 3 years. A story I still like to tell to people sometimes, particularly our co-op students when they complain about the available materials to them for their computer science courses. So I thought maybe we could just begin with asking you a little bit about what you've been up to in the last couple of years and what your current roles are.
Yeah, so a lot have changed since we last spoke. First of all, I published my new book, and it took just 6 years to come to the sequel for my the 100-page machine learning book. So I published it in an entirely different environment, as you know. So you remember in 2019, for everyone, especially on LinkedIn, people wanted to kind of be part of something machine learning, but they couldn't find user-friendly ways to get into the field because, as I noticed back in 2018, if you looked for books about machine learning, you would find textbooks from university graduate programs. So if you don't take a university class and you don't have access to any professor who might guide you through the book, you would find it impossible to read to finish because every equation might be an obstacle. So people just felt too overwhelmed by reading such textbooks, and they abandoned very quickly. So when I published the 100-page machine learning book, it was for people who just wanted to start with something and then progress. And it was a huge success because, well, effectively there were no other books of this kind. But today, who talks about books? Everyone wants to learn with the least effort. So people have courses. People have access to LLMs. But on the other side, on the other hand, uh, LLMs, like everyone is talking about. So, like 6 years ago, it was popular machine learning, but not as popular as LLMs and AI are today. So, I published my sequel for about language models in a completely different environment where people are not looking for information. People are they the information is everywhere. So now the question is how to write a book that people would still buy in this abundance of information. And I think that the format of 100 pages is still good because you still need to have some structure when you self-learn. And if you self-learn with a huge book, well, it's too much for a structure. And if you self-learn with just ChatGPT, it's no structure at all. So I think that this 100-page format, so you read the book, and if you feel like some concepts are missing or you don't understand it clearly, you can supplement it with other sources of information. But again, there is no shortage of information today. So this is very different. I wasn't planning to write a sequel until ChatGPT. I thought that my first book was just good, even 5 years, 4 years, 5 years later. But then LLMs, they added so much new information, so many new concepts, and really it needed a book. So yeah, I published this sequel, and I decided that if I have a sequel, so now it's a series. So if it's a series, I can continue. I can write a book on reinforcement learning and on computer vision and some other AI domains. I decided to resign from my full-time job. It was 3 months ago, and now I live my life as I lived it 25 years ago before I've got my kids. So I wake up at the hour I feel. I go anywhere when I want. My kids are already grown up, so they take care of themselves. So yeah, this is what my life looks like today.
Well, thank you very much for sharing that. That's such a fantastic story, and of course, from our perspective, it's been just amazing seeing you become this best-selling author whose books have been so influential on people. I mean, I just watched a couple of podcasts preparing for this, and everybody's like, these books are on everybody's bookshelf, particularly the 100-page machine learning book, and they're, as I said in the intro, we're reading your own.
No,
That
I
many.
think you see your sales are still ongoing despite say, six years. The book is still very popular, so I see many sales in my statistic every day. So people still learn from books, and people still need some guidance. And I think that this kind of format hit a sweet spot.
Yeah,
Yeah.
I think so too. I mean, it's one of the things about the 100-page. It's just a brilliant format. I mean, the 100-page thing means you go into it knowing there's a limit,
Mhm.
and that's actually very helpful in sort of framing your engagement with the book. But then you start reading them, and you're like, okay, this is 100 pages long. But like, if when I get to the end of this, if I really think hard about everything that I'm reading, I'm really going to understand this area very well, and including with the latest book, the history of it, which is something I wanted to talk to you about. But before we do that, I haven't followed this as closely, but another big change. You're very popular on LinkedIn now, and I think you have over 400,000 followers or something like that.
Yeah.
And for anyone listening who's just curious about how do you achieve that kind of a following on a platform like LinkedIn. I mean, I think you have a daily AI newsletter or a sort of very regularly published newsletter.
Mhm. Well, I think that the most of it comes from my the 100-page machine learning book era. So I think that for the last maybe 4 years, my audience grew maybe 150,000. But the biggest chunk came from the success of my first book. The newsletter helps a lot. The newsletter has almost 900,000 subscribers today. So people receive the newsletter, and they look at my profile, and they subscribe. So the newsletter popularity, this is probably more I should thank LinkedIn for the promotion, because when LinkedIn created newsletters, they gave access to them to only few most popular, I
Oh,
would
interesting.
say, influencer. I don't like the word, but this is how
Yeah.
they call it. I started very early, and I've seen like an avalanche of subscriptions. So LinkedIn should have advertised those newsletters in people's profiles somehow. So I don't know exactly how it happened, but it grew very, very fast. And it's still growing, probably 5,000 every month. So it's 5,000 new subscriptions. So I think that one feeds the other, and I also continue to being very active on LinkedIn, and probably contrary to my kind of not position, but my attitude 6 years ago when I wanted to show people what AI can do, because no one could, well, very few people could really, have hands-on experience with this. Today, there is no shortage on people who can, show how to call PyTorch and apply it to some data set. So when this craziness about LLMs started, and craziness in a bad sense, because like those companies currently who develop these LLMs, and this includes OpenAI, Anthropic, and others, they oversell the product. So LLMs are great, and if they weren't great, I wouldn't spend time like an entire year working like a second full-time job to write it. So I really think that it's one of the most important inventions probably of my lifetime, because well, computers were already there when I was born. Of course, they progressed a lot, but they were there. But this kind of models, it's the first time that I see something big like this. But they try to sell it like it's a step to creating a general artificial intelligence. Like, and when we talk about what the general artificial intelligence is, like in everyone's mind, it's a replacement for for a human brain. So you can say, okay, you can talk to a person, an expert in this domain, or you can talk to an LLM, and whatever you feel like you want to do, the result will be the same or even better with an LLM. But this is not the case, and they try to sell it like if it was. So my kind of direction of what I post for the last I've been posting for the last 2 years was to show people like don't believe what they try to sell you, because they have their motives why they do it. But people are scared. You wake up and everyone tells you tomorrow you will be out of job. So I just wanted to tell people, relax. This is not what it is.
So that's thank you very much for bringing that up. I wanted to very much take advantage of the opportunity to talk to you about this very subject. And one way I think a very interesting way into it before we go on to talk specifically about the book later on is you have when people say they're people like the leaders of the big companies that are getting billions of dollars and tens of billions of dollars in investment, talking about numbers like $1 trillion of investment in processing centers and stuff like that. You've got these three great quotations at the beginning of your book, one of which is language is the source of misunderstandings from The Little Prince. Another one of which is in mathematics, you don't understand things, you just get used to them by John von Neumann. And then computers are useless, they can only give you answers by Pablo Picasso. And the reason I love that is because, I mean, you wrote this book because LLMs are very important to understand, very important to understand well and understand their history. But this idea that this is going to be a machine that just solves all the problems um, partly what it's taking for granted is the idea that all problems are understood and solvable in the first place. So
Mhm.
it's not just often what I find sort of technological optimists will do is they'll say like, if I tell them you're never going to find a four-sided triangle, they're like, well, we don't give up over at my company. We don't think there are any limitations to what we can do.
Mm.
Um, so I was wondering if you could take a moment to talk a little bit about what are if like let's say I'm some member of parliament, I'm a cabinet minister for a G7 country, and I've been told by everybody around me this LLM AI thing, I have to get my whole country invested in it. We need to have a new cabinet minister for AI and LLMs. We need to be subsidizing hundreds of billions of dollars of data centers for these things. If you could have their ear for like a couple of minutes, what would you say to them?
Well, we already have I think, a minister here in Canada, a minister of AI.
That's kind of why I brought it up, but yeah.
Yeah, I think that like if you create a minister of AI, then why wouldn't you create a minister of computing? Because computing is like, because AI is part of computing. So you have computers and then you run AI on them. So everything that AI can do, a computer can do. So why didn't you have a computing minister? So there is a lot to hype, a lot about hype today. So, oh, everyone talks AI, so we need to invest in it. Of course, you need to invest in it, but you should treat it as any other technology. Okay, so you don't have a minister of smartphones, right? But smartphones revolutionized our lives. Like before smartphones, even like I would have several devices at home, and none of them would connect to one another because well, we had wires of different shapes, and then in internet, and then Wi-Fi, and then smartphones. Now we are connected everywhere, and you can connect to basically any other device and to any person anytime. Like we are speaking right now, but we are in different places. And before COVID, it was also very hard because these multi-person conversations worked maybe for two, three persons at the same time. But today you can call 1,000 people in the same room and present, and they can ask questions and so on. So all these technologies are equally important. So AI is just one of the technologies, and as any technology, it comes with some benefits and it comes with some limitations. So today, saying that AI will do this and will do that in like next year, in 5 years, no one knows it because like we have these LLMs today, and they can do something because, well, you ask some question, you get some answer. But the problem with this technology is that you don't know exactly what it can and what it cannot do. So, like for example, if you use it for coding, you can say, "Oh, wow, I just typed, write me the application which would be a Tetris game." And it writes it to you, and you run it. Oh wow, you just click play and you have Tetris. Why it can do it? It's because it was trained on a lot of examples of how Tetris can be programmed. But if you apply it to your own very busy, like domain specific problem, like for example, you work for a company that produces some specific chips. Okay, so very industry specific chips. And then you ask an LLM fix a problem with this chip design. It will not do it because it was never trained on anything like this. And chip designs are rare compared to any source code or books or online articles. So we can kind of say that if your request falls into something that people commonly share online, then you have high chances to get an answer, and this answer has high chances to be good. But we cannot say if I just deviate just a little bit from this common question, how good the answer will be. No one knows. So today people talk a lot about what it will be in next year, in 3 years, but to be honest, no one really knows what it will be. And today it's still more like a toy than the real thing. That because even if those companies that have crazy valuations like Cursor, it's a text editor. It's a text editor that can send your pieces of your code to an LLM and ask for fixes. Like anyone can code an editor like this in a matter of a week. But they have all crazy valuations. But the practical benefit wasn't proved by anyone. So I would like, if I give my advice to politicians, I would say keep an eye on this technology, but don't get again too crazy believing all the stories that next year it will be X and in 2 years it will be Y.
Yeah, that's such a very good answer. One thing it reminded me of, I've got this old joke about uh, to explain particular to people in particular why Gmail sucks for email, and it's like if you've ever sent an email where you could go to jail for making a mistake, like in who you sent it to,
Mm.
or what the content of the email is. you're not going to want to use Gmail, and you'll see right away what the weaknesses of its design are. And I think
Yeah.
a lot of that is true in particular for people's use of LLMs. For example, like if you're going to be designing a, I don't know, a satellite delivery rocket, are you going to use an LLM to sort of make the final decisions about what to do? Absolutely not. Because one tiny mistake and it blows up over Florida or what have you, right? And one thing I know you've talked about in the past is that you can't debug LLMs or swarms of LLMs.
Mm.
So this it's not only that, like, you still have to check them for their results, and you have to actually understand the problem or the issue well enough to judge whether the answer is good, but you can't even kind of go back and really fix what the problems are in a fundamental way. Is that true? Am I very off the mark there, or am I in the right direction?
Well, yeah, so we can talk about agents later, but the point for everyone to understand is that um, if you use a tool and you don't know what this tool can and cannot do, it's not a tool that will change everything tomorrow. Okay, so like if you are a carpenter and you use hammer, so you know how to use hammer, you know what it can do, and it can, hammer clues, and you can also make holes in the drywall with a hammer. This is all. Okay, so this is the tool, and you know exactly what to expect from it. AI, it's a tool like with a gotcha. Okay, so you kind of, I
Right.
will try it. Maybe it will solve my problem, maybe not. But when I try it myself, so I, Andrei Burkov, I want to solve my personal problem. For example, I have a problem that Spotify doesn't recommend enough good new music for me. So what I did, I used an LLM to write a Python script that will download my liked a list of my liked songs, send it to an LLM, and say, okay, this is what I like. Now generate a JSON output with 20 new songs that I might like. I solved my personal problem, and if I didn't solve this problem, I would be fine. Okay, there is still recommendations from Spotify that I receive 2 times a week. The one is Discover Weekly, and another one is Release Radar. So I'm fine. I can survive. But if I am, let's say, a company that develops something important for clients, okay, so the client comes in and the client says, I have this problem. Can you solve it for me? So if you say, of course, I use these LLMs to code, so I will code it for you very quickly. No, you will not, because you don't know. You have zero idea whether the client's problem looks like the training data these LLMs were trained on. So you will say, yes, of course, I will do it. You get the problem definition, you describe it to an LLM, and you see that LLM is useless because it just tells you nonsense because it is out of the domain on which it was trained. So you will fail. So your company will fail. You cannot really commit to anything. You cannot say whether you can do it. And if you can do it, you cannot say when, because again, my example with Spotify worked like this. I was taking a breakfast and I just typed one prompt, and and right away I've got a working script that did exactly what I needed. Cool. But now I work on another project, and it's a struggle. Every mini adjustment I want to apply to my code, it's a struggle. It doesn't understand what I want, and the code base grows. So the more you give it, the dumber it becomes because it wasn't really trained on such large inputs. So no, I cannot even tell whether I will finish my project, or I will say, you know what, I will put it on hold. I will wait for probably smarter models or models trained on more data to come next month, maybe next year, and I will get back to it and probably I will finish it. Because otherwise, if I say, okay, LLMs don't work, then I will have to learn React. So I know JavaScript, like basic vanilla JavaScript, but I have no idea about React. I must learn everything about databases, security, DevOps, so many things to learn. So my only solution would be to hire people and continue to push my kind of a prototype to production, but it will be very expensive. I will need to spend time to build the team and so on. So you cannot really rely on such technology for business. This is why I say it's a toy. It doesn't mean that it's useless. It just means that it's not ready for business, and there is no one, there is zero people on this planet who would say that eventually and when it will be ready for business.
And so do you think that we're going to approach something like the .com bust that happened in the late 90s, early 2000s? Um, is there going to come a moment when sort of everybody realizes, oh my goodness, there's just these limitations? I mean, in a very different way from what the problems were then, but similar
Mm.
with respect to hype and fear of missing out and trying to be competitive and stuff like that. Do you think there's going to come a point where even the hype builders are going to have to be faced with the reality of the limitations of what they're trying
They
to
are
find?
already faced. Like
Okay.
just listen how the rhetorics of Sam Altman and uh, Nadella from Microsoft and so many other folks changed. Now they say, don't talk to us about AGI. AGI, like we cannot achieve it with LLMs alone. AGI will take, well, for those who aren't aware, AGI, it's artificial general intelligence. So, like, because when ChatGPT was just released, these people hyped like, okay, we are very close to AGI. Like, we just need to train a larger model. We just need to get more data, and it's like a done deal. Just give us. They gave estimates like in 1,000 days, next year, and so on. Today, no one talks about it anymore because people start asking questions. Like it's been already almost 3 years. Where is GPT-5? Because GPT-4 has been released almost like 3 months after GPT 3.5. Where is 5? They changed this rhetoric. So what will happen? I think that comparison with dot coms, it's not exactly similar because dot coms collapsed not because the internet wasn't good.
Yeah.
It collapsed because the expectations that it will, all start to work, all start to generate profits very fast. Didn't so the investors just didn't believe that they will get their returns on investments fast enough. With AI, it's a different story. So it's a very strong technology, but we cannot even tell whether it will become reliable enough for business. Because with internet, it was just a matter of time that we have so many people connected, right? So because when I started to build for like websites, it was 1998. So it was well before even Google and Facebook and so on. And in my native town, I was among the 300 people only who had this how do you call it, fast internet connection even before ADSL. Like it was just my phone line wasn't this copper wire. It was more like a synthetic fiber wire, and it was already like, oh my God, I'm in the 21st century almost. So I saw that the only problem with dot coms was that we were too early. There were not enough people online. But now, like we have, I think, 4 or 6 billion people online. Of course, it works. Of course, it's a huge economy because we are now all connected, and your .com website that you started in the early 2000s today would generate good profits. So we could calculate for .coms that, okay, we have 7 billion people on the planet. Currently, only, let's say, 300 millions are connected. So we just need to stick around and wait until at least a couple of billions more connect. And it will be, this, what they call synergy, okay? So, or a critical mass attained. But with AI, especially with LLMs, we cannot tell it because they say we need more data. But where this data will come from? You will not invent more books. You will not invent more code. So like everything that was scrapable was already scraped. I'm sure it was already scraped 3 times. So now what is your next idea? And there is no next idea. There is no next AI paradigm that would say, let's just wait a little bit because this thing will take time to mature. No. You need to tell me exactly what is your next step other than growing the size of your LLMs, and other than, there is reinforcement learning probably, like they might say, yeah, let's use reinforcement learning. It will probably, patch some holes in coding, but overall, the tool will still remain unreliable and unpredictable. This is the problem.
That's funny you say unreliable and unpredictable, and like in the context of a discussion of what's artificial general intelligence. We all actually, most of us all the time when we talk about this, we just leapfrog over the question of what intelligence is and what human intelligence is, and then we just think we know it because we embody it ourselves. But I've got this joke that we've already achieved AGI. The hallucinations and the short context windows are proof. If you've ever heard me go, for example, go on about the Montreal Canadiens from 10 years ago, I'm probably after 3 pints, I'm probably making up most of it. And Are there? I wanted to give you the opportunity. Is there anything? And of course, it also often that question leapfrogs over the fact of human difference, right? That we're all very different from each other, and if we're self-conscious, we're even different from ourselves. Are there any thoughts that you have about what the sort of like what element of human psychology is it that is most difficult to
Well,
replicate in computers?
yeah, yeah, I thought about it a lot, and I came to two conclusions. The first one is that understanding in people, it's a feeling. So it's not some combination of signals that come in your brain that are different from when you understand and when you don't. It's a feeling. So basically, when you're, let's say, you are a talented physicist, okay? So you develop a new physical theory of some phenomenon, like we can observe. So at some point, your theory will be complete, and you will say, my theory is complete, and you will feel great about it because it's all now well placed in your head. So you can sit and say, well, I will open my bottle of scotch and enjoy because I finished my theory. So this is something that you can never get from an LLM, because an LLM, it will always generate you some corrections. If you say this doesn't work, oh okay, I will fix it here. No, now this doesn't work. Oh okay, I will fix it there. So the LLM, even if it tells you now, it's like, for example, you debug a problem with your code and you give it the code that you have, you describe the bug, and it will say, I know this is the fix. So you apply your new code, you run it, doesn't solve the problem. You say, didn't solve the problem. Okay, that is the fix. So no matter how hard, how many times you return to it, eventually it will start saying, okay, this is the final fix. So it will give you the final fix, you apply it, and it still doesn't work. So it will say, oh, I'm sorry, now this is the final fix. So it will never reach a state in which it will say, okay, we exhausted all possibilities. So at this point, if it doesn't work, it's not a software problem, it's something else. And even if it tells you this, it still might be wrong because it never, so what you read never 100% aligned with the reality. So this was my first understanding. And the second understanding is that LLMs, when we read something from generated by them, we are we it's not that LLMs think and can produce the text that represent their thoughts. There is no thinking inside them. It's us. When we read some sentence, we give it kind of an impression inside our brain that this is a reflection of someone's thought process. So basically, because we have got tens of thousands of years of evolution where we communicated with other human beings, and then when we invented writing, we started to communicate in writing. So by nature we evolved into some entities, some species who anthropomorphize anthropom yeah anthropo, anthropo, anthro,
Anthropomorphize.
anthropomorphize uh, reading. So you read, and in your head, it's you kind of assume that it was written by some other person. But when LLM generates this sequence, it was fine-tuned to fool you into thinking this. Why? Because it was fine-tuned to perfectly predict the next word given the preceding sequence. So when it learns to perfectly predict the next word, then for you as a human, it will look like if it was a person who, like a real person who wrote it. So we don't know what exactly is going on in these parameters inside the LLM when it just makes a decision to generate the next token. But we can think that, oh, some thinking is going on there. This is why it produced this output. No, it produced this output just to make you believe that this output makes any sense. And this is why the size of the model was so important. So if you try to train an LLM with less than 1 billion parameters, you will see that the sentences don't make sense. So your human eye and your brain reject it right away. No, 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 it's not this. But then when you grow the model, eventually the sequence of words becomes so indistinguishable for you from what a real human would write, you stop seeing that it's fake. So at this point, no matter the size, you can grow it as much as you want, but you
Right.
already fooled. You
Right.
already feeling like it's a real deal. But yeah, so I think distinguishing the real thought process that results in some writing versus just writing that makes you feel that some thought process was there. It's important for people to understand the limitations of these models.
One last question I very selfishly wanted to ask you about the general state of AI is I remember when I first interviewed you 6 years ago. Self-driving technology is one of my outsider kind of headline reading hobby horses. And
Mhm.
just recently, I think it was just today or yesterday, Tesla finally launched some micro version of its robo taxis in Austin, Texas, I think, or something like that. And I remember asking you what's your opinion of the state of affairs based on everything back then, and I remember part of your answer was AI is going to, well, not AI, the technology is going to be really good at the kinds of things that come to us naturally. Like if all of a sudden something darts in front of the car, your brain goes bah, and it kind of knows to hit the brakes or something like that. I seem to recall that your answer was something like that. But in any case, what's your sense of the current state of self-driving technology, and where do you think we're going to be at 6 years from now? Is my selfish question.
Yeah, well, self-driving, I think that people had a lot of expectations from it, and today we see that it started as a small project. So the problem with self-driving is that humans are unpredictable. We just talked about LLMs. The problem with that is that um, AI needs to, when it makes prediction about what the car in front of it will do, it has to account for the unpredictability of humans, and this is very very hard to do because you don't know what the person can do. So this is the first thing, and the second thing is that why they start small, why they start in some specific part of the city and not deploy it at scale everywhere. It's because currently, to make it safe and reliable, you need to train it specifically for some streets. Okay, so you put a driver, and the driver runs the streets, and the system adjusts to know. Okay, so there is a construction on this intersection, so you need to be aware of this. Here there is a lot of people always crossing, so you need to take kind of keep an eye on this. So like if you fine tune a machine learning system to some data set, and like these streets, it's all one huge data set. Then it will work well in this specific scenario. But if you take this car and put it somewhere in India or in Canada, in Nordic regions where there is a lot of snow and these sensors can be blinded because of dirt and so on, it will be very hard for this kind of systems because again, well, they were not ready or not trained to this specific condition. So it wasn't unexpected for me that robotaxi will be there. Because if you really fine tune it to some specific part of the city, what problem can be there? So, like you made multiple back and forth on all these streets. What can change? Yeah, tomorrow they will start renovations, but because it's such a small part of the city, you can always turn off this specific intersection while the renovations are there, and the car will just take a detour. So like yeah, like it's typical machine learning projects. You have data, you have performance, but globally, it's hard to imagine that you can have a global training like training data set that you can, because it's a model in the end, right? So if you want this model to drive, you need to put this model inside the car. It should be a computer. It's already a computer, and I'm sure it runs maybe one to maybe two, maybe three GPUs inside. So these GPUs are limited in memory, and if you want to your training set to be taken from all places in the world, today it's hard to imagine. But to for a small part of a city, especially like Austin, with nice weather conditions, nice work, a nice street, like the street quality, yeah, it might work. Why not?
Okay. Okay. Great. Yeah. Thank you very much for that answer. And maybe 6 years from now, I'll get to ask you again. Um, uh, just moving on to talk a little bit about your book. Um, uh, without one interesting thing I wanted to mention to people listening, if it's been some time since you've done your calculus, you'll have to brush up on that a little bit. But Andrew's very good at walking you through step by step the sort of math in the book, and using actually something like Chat GPT to help refresh your memory. What's a first derivative, things like that.
Mhm.
It's actually very helpful. I use that. But without going into all the details of the math and stuff like that, one interesting thing about the book, and I think one of the motivations for writing it was the telling something about the history of language models, and this kind of math and this kind of analysis that wasn't born from nowhere 2 or 3 years ago, and all of a sudden they made a graphical user interface for that was fun to use for Chat GPT. So I was wondering if you could just talk a little bit about that, about what's the history of this science.
Well, why I was especially excited about being capable of showing the history is that I have shown three types of language models. One is count based, one is recurrent neural networks, and then transformers. But what is cool is because I didn't want it to be just a history lesson, so I was lucky that actually all three are currently used in production. Natural language processing systems. But for example, you use your smartphone, and when you type some word, it completes it based on what you typed yesterday and last week. So no neural network is used there. It's in like just a count base. So it sees that after you say hi, you often also type some emoji, and it suggests you this emoji. So there is not really much of this hyped neural network technology, but it's still useful. And this was the very first attempt of computer scientists, linguistic scientists to create a talking machine by counting the words. So if I see that you type the weather is, then it's most likely that it will be rainy, or the weather is sunny, but it will not be, I don't know, elephant. Yes, and it worked very well, and now it has its application in smartphones. Then recurrent neural networks was the first attempt to, because the problem with counts is that it's very difficult to store them, because like if you want the continue like the next predicted word to be as useful as possible, then it's not sufficient to give it a context of 3, 5 preceding words. It's okay for when you type on your smartphone, but if you really want it to talk to you, then you need to show it a history of conversation much farther than five words. And you can see like it's a combinatorial increase in the number of possible prefixes. So if you add each additional word, it explodes in the number of all possible combinations that you will have to store. So storing all possible, for example, currently Gemini supports 1 million token context. Like if you just imagine storing all possible sequences of 1 million words, there is no place on in the world where we can store all of this. So the next thing the scientists started to think about is like how to overcome this combinatorial explosion in the number of sequences to condition your prediction on. And when neural networks have become like deep learning started in 28, 29, yeah, 28, 29. So 2010, it was already a big deal. So scientists learned how to train large neural networks. And then again, the question of can we, instead of storing all these counts, can we just train a neural network that will take any sequence and then just predict what will be the best next word in this sequence? And this is how eventually recurrent neural networks have been invented. So instead of, putting an entire sequence in the model, because how you can put a sequence in the model, they decided, okay, we will take one sequence, one token at a time, and it will update an internal state in this model. And once all these tokens are read one by one, then we will say, and now what? And it will say, and now this. And it worked very well, but again, because of limitations, this approach, reading the sequence one word at a time, was very slow. So, for example, if you have a million tokens to input, then you have this, you need to run the prediction million times until you can make your next token prediction. It was very slow to especially train such something like this. So it was kind of abandoned for a number of years, and then everything changed with the transformer, where they said, well, instead of reading all this entire sequence one by one, we will actually read it in one shot. But to preserve the sequential information between the tokens, we will inject into each token numerical representation some disturbance that reflects its relative position to other tokens in the sequence. And this is why it was revolutionary, is because when you remove this sequential part from RNNs, suddenly you can train very large models, because this sequential part, this is what was slow. But then when scientists saw that transformers actually can be trained so large that they start talking, then they revised the architecture of RNN. And now even RNNs, that there are RNNs that are not sequential anymore. So now RNNs, there are some models that work as good as transformers. So today there are many different architectures of neural networks that can be applied to sequential data, but the limitations are the same. The limitations are that the training data doesn't grow on trees. So you can use all the data that the humanity generated. You can train very large models so that it will really remember all small details of your training set. But in the end, if you're asked a question that wasn't well represented in the training set, you will get a wrong answer, and the model will never tell you that it's not sure about this answer, because neural networks don't have a built-in mechanism that would say, okay, I trust this set parameters more than this set parameters. There is nothing like this in the neural network architecture. So no matter how hard you try to fine tune it for some task, or to surround it with different guardrails, in the end the model will always say, yes, I'm sure, I'm really sure, but it can output a total nonsense after saying this.
Yeah, no, thanks very much for that really great explanation of some of the history of the technology. And one thing I really like about the book and the story you just told is that, actually a lot of people often think that sort of understanding the sort of something scientific, as it were, you just need to understand right now the state of affairs, but actually understanding the progression of things over time is a part of understanding where we are now sometimes with some things. And that can be really important for communicating with other people, for understanding whether you've made an innovation or not, and things like that. In the last part of the interview, when the guest is a Leanpub author, I always like to ask them about their writing process and stuff like that. And believe it or not, there are people who skip to this part, the content creators and authors and stuff like that. So I was wondering, what was your approach to writing this latest book? Did you block off time, like, tell your family you can't talk to me Saturday afternoons? Or did you do it kind of more randomly, like when the inspiration hit you to just go work on it again?
Oh, no. Well, when I worked on the book, I worked after my day job. So I made dinner with my kids. We watched some series or movie, and then I tell my kids, okay, I will go and work. And yeah, so I worked in my room. As I had inspiration, or I was just not too much tired, because sometimes you try to focus, and you can't. So yeah, no, it was like this. Basically, every evening I try to, because I have a rule, like if you want to finish something, especially like a book, you need to write X number of pages every day. So if you do it, like, because they say, but it will take so much time. Yeah, but time will pass anyway. So no matter whether you do it or not. So if you just say, okay, I need 100-page book. So if I write 3 pages every day, then I need 33 days. But like, it's in an ideal world. Sometimes I can write 4 page, sometimes five, but I keep this minimum of three as a rule. And even if I don't like it in the end, it's okay, because in the end, for example, when I had all my book complete, it was about 200 pages, and I needed it to be, to fulfill the promise of
No problem.
100. I needed it at least to be below 150,
Mm-hmm.
because if it's like 145, you can always say, well, if you round it to 100, well, it's closer to 100 than to 200. So yeah, so I ended up having 200, and then I started to see what I can remove, what I can simplify, and this is when LLMs are really helpful, because there are two very great, very good use cases. The first one is to condense some information, because sometimes you express your idea with too many words. Like it could be expressed much simpler, simpler not in the sense conceptually simpler, but simpler in the sense of not using so many words. So sometimes I read my paragraph, and I just communicated such a simple idea. Why it's a full paragraph? So you can ask an LLM and say, reduce the size, but keep all the details, like technical details mentioned, intact, and keep the style also. Like, don't rewrite it as a 5 years old. So it will do it, but of course it will reduce something, like it will remove something that you would not remove yourself, or it will replace something with something that doesn't make any sense when you read it. So like you always have to correct after it, but it will give you kind of 80% of something that you can work with. So this is one, and the second is validation, because it's a technical book. It's very easy to make a mistake, in any calculation in the code and so on. So ask it, and I really like this approach. You say this code does contain an error, and you don't know it, but you say it does contain an error, and it will say okay, and you say find it, and it will do all possible, it will try all possible ways to convince you that it has found an error. So when you actually see that it's a real error, then you are happy and you say cool, I will fix it. But when you see that it tells you, oh, I see an error, the error is that you didn't add a comment above this line, because a reader would not, for reader it would not be clear, so you really need to put this error. So now you see that the error that it finds, it's ridiculous, it's nothing. So the chance that there is a real error that it missed, but it decided to talk to you about this common thing, it's negligible. So I think that for validation, LLMs are great. I think that people will miss much more. Any corrector, any proofreader, any human can be tired. Okay, human can be distracted. LLM will never be tired or distracted. So like validation, it's a perfect use case for writers. And yeah, condense something that you feel like it's too verbose to.
Yeah, thanks very much for that. It's you reminded me with respect to long-term independently driven projects like writing a book or doing a doctorate. I'm definitely a big fan of actually having kind of, as it were, concrete targets rather than time-based targets for your day. So
Mm,
like you said, 3 pages. I had one friend who was like one paragraph, for the writing part or something like that. But for me, it was I had to read 100 pages a day.
mm,
And I remember saying that to some people, and they're like, only 100. And it's like, well, yeah, some days it's only 100 because it's a 17th century English grammar that's this big with margins like that. Other days it's
mm,
100 pages of Heidegger.
yeah.
And then, but if you, it's partly psychological, right? You can know you've reached your target, even if it's
Mm,
not a good 3 pages or an easy 100 pages to read or whatever it is your target is. Having those stable things are very good, not just for progress, but for your own mindset
mhm.
as well when the very long term self directed projects. Um, the last question I have for you, and this is the question I'd like to ask guests if they've been using Leanpub, is if there was one. I know you used our upload writing mode, so you can use a sort of like there. This is a sort of limited question to you, but if there was one magical feature we could build for you on our platform, or if when you're using Leanpub, there's one thing that has you shaking your fist, going, "Damn you, Leanpub! Why does this suck so much? Why don't you fix it?" Is there anything you can think of that you would ask us to fix for you?
Well, I think the UI needs to be. No, I know that you already have this in plans. It's always confusing for me when because it's like one UI for both readers and authors. And I
Yep.
think that doing this, like you probably have two different doors. And once you choose this door, then you are an author. And once you choose this door, you are a reader. This would be really helpful. Other than that, well, probably you will not be able to do it easily, but I would like to know whether some specific book would be interesting for me and would make me feel like I'm not wasting my time. It's like, for example, Netflix, when they say they show the thumbs up and say, "We are sure you will like it." Many times they are right. Okay, of course you have fewer probably content to build such a recommender system, and fewer content, fewer users, but yeah, because there is as I said in the beginning, today there is no shortage of information, there is no shortage of how you can be entertained. Like you can be entertained with music, with series, with movies, with talking to chatbots or whatever. So today I would like to know where should I spend my time with, and what did I miss? Okay, so yeah, something like this. Like, tell me what I will like.
Yeah, thanks very much for both of those suggestions. I get the one about the design of the website quite a bit from authors, and it's exactly for the reason you described it. That Leanpub is a platform for people to uh, discover books and courses and to buy them and read them or take them, and then it's there for people to write books and courses and create them and then distribute them to people. Those are two
Mhm.
very different things, and to sort of the way Leanpub's currently designed, there's no clear kind of door you pass through to get to what we call the author app or something
Mhm.
like that. The menus kind of look anyway. It's something we're working on very hard for something we call V3 of Leanpub. There's going to be a complete redesign of everything, and hopefully it will address a lot of those issues. And when it comes to recommendations, I think we do have a kind of a very simple recommendation banner on the bottom of your Leanpub library if you go there.
Okay.
And I do think we show something after you buy a book at the bottom of the page, but that's definitely not something that we've invested a lot of time or energy in. And that's a very good point that you're making about like discoverability, and recommendations are actually like the big challenge for platforms like ours and for people who want to
Mhm.
use them in a world where there's so much content. Well, Andre, thank you very much for taking the time out of your evening to talk to me and to talk to all of us about what you've been up to in the last few years and the current state of AI, and maybe a little bit about its future, and your book, the 100-page language models book, Hands On with PyTorch.
Thanks, Len, for having me, and hopefully we will have a next chat next year when I will finish my reinforcement learning book.
That would be fantastic.